Hello and welcome. In this video, I'm excited to present our project that is contextual language understanding with transformer models that is elevating the NLP natural language processing capabilities. Today, I'll walk you through the entire journey from the data preparation and model training and deployment and creating user interface. To start off with my introduction, hi, I'm Mohammed Faisal. Our project focuses on harnessing the power of transformer models for contextual language understanding. We aim to build a state of the art question answering system that not only extracts answers from text but can also handle questions where no answer is present in the context. Throughout this project, we leverage some advanced models and went through different data set and different versions of the data set and from small to the whole data set to basically create our solution to our problem statement. Um, so our main objectives of the phase one, let's start off with phase one. The main objectives that we set in phase one, we set in phase one. Yeah, as you can see here, we are just telling key we'll develop a transformer based model for question answering tasks, ensuring contextual understanding and accurate response generation. So in general, I'll tell you the objectives of the whole project, not the phase one. The whole project is basically to build a robust Q&A system using transformer models that which we will use the Squad 2.0 dataset. Like we decided on the Squad 2.0 dataset. Then we'll fine tune and evaluate a pre-trained model. Then we'll deploy the model with an interactive interface. Then we So basically we identified our problem and identified the data needed for our project in phase one. Then the data set we selected was the Score 2.0 data set because it presents, obviously, as I told, a unique challenge which it includes both answerable and unanswerable questions, so that this ensures that our model not only extracts answers accurately but recognizes when a question has uh, no answers in the provided context. So we will go through that example as well. I will show you that in the ahead. Then we then pre-process the data using tokenizing the questions and context, then applying truncation and padding and aligning answer spans to prepare it for model training. Like for model training, we do this in model training, but we are not necessarily doing the model training here because we it's computationally very enormous. I will tell you ahead. So the truncation, padding, and lining, all that will come in phase. I'll tell you detail when I show the phase three PDF. Then in phase two, basically our whole point was of data pre-processing and model designing, where we'll find the missing values present or a missing context or questions fields were flagged or removed, and we'll also remove outliers. That is we need a specific length. Truncation is basically if you have a specified length, we will limit that to a specified length so that the remaining overextended one we don't use it. So yeah, removed if deemed irrelevant for training. Here you can see. Sorry. Then inconsistencies, like if you find any mismatch in the question, in the context, question and answer pairs, all these were resolved. Then in feature scaling, uh, one hot coding and all that, we went through this. uh, Tokenization, yeah, but we basically did use bird initially to train the model, to try and train the model, to try and train the model because it was very difficult. uh, I will come to that in a moment. Meta features, yeah. So then okay, just okay here. Yeah, model training and validation. Here we'll obviously even chose a batch size of like 16 and number of epochs to 10. 10 was very 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 large. We tried doing it with 3 and a smaller version of the data set. The squad data set is like huge. It has so many number of rows, like I don't know, some 300,000. So we'll not 300,000. So I'm not sure about it. I can show you the data set. Yeah. So we tried, yeah. So yeah, we tried running 2 3 epochs with a small data set of like 30,000 entries, and it took us like 110 hours to train the model, and it couldn't even complete the training down 5 hours or 6 hours in Google Colab using like the fastest free GPU or the TPU that was available on Google Colab, and it says ki the computational power had exceeded, and I had to like pay if I want to use more. So with the small one only, it would take us such a huge amounts of time. Sorry. And then so yeah, so like our focus like entirely shifted to finding a pre-trained model. Then we went through lots of pre-trained models. The small, again, the 30,000 one, we went through that as well. There was a pre-trained model for that as well. Then we decided ki since we are anyway doing a pre-trained model, let's do it the whole version. So we went ahead with this roberta base code 2 here. Roberta base code 2, this pre-trained model. Yeah, this is a Roberta large model, which was oh yeah, which was done by DeepSet. Uh, so it's already been trained on the question answer page and including unanswerable questions for like task of question answering. Okay, wait a minute. Ha, uh, what was it again? So yeah, we chose this Roberta, this basically model. The which has been which yeah, as I said, like we selected this pre-trained model DeepSet Roberta base hyphen score 2, which like this has already been fine-tuned as well on the score 2.0 data set. So retraining such a model, as I said, would be from scratch, would require enormous computational resources. Originally the model here was like fine-tuned on like 4 Tesla V100 GPUs. Like that is just insane amount of computational power. So instead we like leverage this pre-trained model to adapt it to our needs. Then if we needed to like train it more or like fine tune it more, we could have done it using the Hugging Face Trainer API itself. But we didn't need it because it was already so fine tuned. All the like context and all the questions and answers were working very perfectly. Then we found the performance metrics as well for this. Like we can find the exact match and F1 score and all that accuracy, which I'll show you here only. Yeah, here you can see the like different metrics as when it was done key, where the extra exact match came about 87%, and like the F1 score was around 93% and 88% here. And so yeah, so this was just the history, and I can say it's pretty accurate as well. So here you could see they had trained here using the Tesla V100 GPUs. I'm like sorry that I can't find it right now, but yeah, I can go here. Yeah, let's talk about here. Yeah, so here we have like in the PDF as well. I have mentioned here key like to train it. It's like computationally expensive and enormous. and it was fine tuned on four Tesla V800 GPU engines. So let's say if you want to do it, like if you want to again like tokenize it and like fine tune it more, we can use this particular code snippet where we could like uh, basically import the model that is the deep set robert base code 2. Then we could yeah, then we had to load the squad 2.0 dataset, which you can do it from here. Before doing this, we probably have to run the pip install dataset so that the datasets are installed onto the Google Colab. I will provide a GitHub link down in the description as well, and in the project submission in the phase 4 report as well, report link, so that you can go look at the Google Colab and run it on your own as well with the user interface. So here, tokenizing and pre-processing. Let's say if you want to tokenize questions like with the context and maximum space and like max length, here we are given as 384, and truncation is like only second, and padding is like should go with the max length and all that. We could also remove offsets like mapping for questions like the remaining which from the max length which would like remain, right? So that we could like offset it as well. Yeah, then we then like extract the training and validation splits, which is the training data set and validation, which training here was around 80%, I think, in that Robert in which they have done it. There is no publicly available source code of their training model, training trained model source code. But I have read it, and it says around like 70% of the training data and like 30% of the validation data, I guess. Then the model here, yeah. See, model was trained for three epochs of batch size of 16 and with weight decay of 0.01. Weight decay, it's basically weight and biases which yeah, it's already provided by Hugging Face as well. If you try to run it or make your own general model from this, what I have given in the PDF, so you will probably have to log into Hugging Face and uh, weights and biases of Hugging Face as well, and all that. And the learning rate here is also given, and so at final we tell here to train it. You can go through this code, which it'll be there in the phase 3 of the PDF. So learning rate scheduler is basically like it helps like to adjust the learning rate like dynamically like during the training, so that like it can like cover a large data set like more efficiently. So we'll set up the learning rate scheduler as well here. Then model evaluation and inference. So model evaluation here we could like load your own metrics, that is again for the squad data set and like exact match and FN score, where I have already shown here what are the exact yeah, exact match 85%, 88%, and 87%, 93%, and stuff. Um, yeah. Then to like then to run the pre-trained model, we have to develop a pipeline basically, like for real world usages. Like we demonstrate inference using the Hugging Face pipeline. Basically this shows how the model processes a given context and like how to respond to a question. So basically here is a pipeline where is a question answering, and model is basically the pre-trained model which I've already imported, then tokenize it, then the context is this, and the result is in the result where we have asked the question of what is the capital of France. So it has to give the capital of France as answer, so it has to print the result as answer, where we I can show you this and run it as well. So here, yeah, let's run this. So here the context I've given here is the Stanford Question Answering Squad is a popular dataset for training machine reading comprehension models. It consists of Wikipedia articles within question and answer spans. So question will give is what is squad. So it should run the pipeline and it should show the result here as answer. What is the answer here? The Stanford Question Answering dataset. So what is squad here? we have given in the context. So let's say we use a different context. What was the context given here? The capital of France is Paris. So the capital of France is Paris. It is a beautiful city. Now, what is the capital of France? Let's see what she's gonna give. Paris. See, so the answer is here given so to Paris. So as again here, yeah, here in the conclusion of phase 3 we can see that key like we use like we provided like detailed step for like loading, tokenizing and pre-processing the scored 2.2 data set so that it ensures the inputs are well aligned with the model's requirement. Then we like fine-tuned it using Hugging Face trainer API and coupled evaluation metrics. And since the original training was performed on four Tesla V400 CPUs, uh, it is high. It has a high computational cost, and like it requires expertise and like time requirements as well because it's going to take time. I think it took around like half an hour for them to train on the four Tesla V100 GPUs, I guess. So imagine the amount of computational power we needed to run this particular uh, project, basically. So some of the applications where we can say is basically LLMs. So LLMs usually need high computational powers, and this is one of the examples of LLMs. Kind of an LLM where we can some it's one of the applications. So basically, so yeah, here you can see like the proven model performance as well, where yeah, it says ki 79% was the exact match and like 82% F1 score. Where I showed more ki there were somewhere with more and stuff. When you keep updating it, does keep happening when that is happening. Yeah. So then going to phase 4 basically is of oh, sorry. So phase 4 basically this is our whole user interface where it's going to create a simple live web interface where you can do it. So we can import this to VSCN as well and do it, but like Google Colab is like much more better, like in the sense it anyway requires more computational power. So having a faster GPU where it's running on C, it's running on the TPU. Yeah, it's running on 8 TPU basically, which is like I have so much of RAM here, man. I have like 400 GB of RAM. So this having this on you take us around like 150 hours to train the model if we tried doing it and we still couldn't like complete it because it would ask us to pay. So this was basically the like we needed so much of computational power. Then yeah, going on to phase 4, sorry, I was lost. So yeah, going on to phase 4, we developed an interactive interface using like Gradio. Here as you can see, Gradio allows us to like create a user friendly web application where like users can just enter the passage and questions and instantly receive the model's answers. I'll show you here. So yeah, let's launch the app. Second step. Cancel. Yeah. So now we can run it. So I'm gonna run it. Yeah. So you can get the interface here as well, here only, or you can go to the live version here. You could access it from here as well. But since it's already loaded here, we could do here. Okay, it's fine. We'll do it here. So let's say we give an example of open AI developed Chat GP, Chat GPT. It is a very useful and powerful tool, let's say, and we'll ask who developed ChatGPT. We'll submit the question. Let's see what's it going to show. To OpenAI. So yeah, see, OpenAI. Roman technologies conducted skill conducted skill enhancement training skill. Question: what did Roman technologies do? Gave skill enhancement training basically to help us upskill. So we can flag it, and it's gonna flag it and tell key okay something wrong about it, and then we can like fine tune it again. So that was basically our project. So we had I will put the like to like give any commands or like to tell us anything you can comment down in the comments itself or like the to like collaborate and like help us further like learn and stuff and like to teach us anything like we have like the code is available in GitHub like link in the description. And in summary, our project basically demonstrates like the full cycle of like building a robust Q&A system and what using transformer models and what we went through and our difficulties and how we chose a pre-trained model and how we ran the pre-trained model to do it as well. Then we like started with define basically start first we started with defining the problem and like preparing the score 2.0 data set. Basically we got the score 2.0 data set which is publicly available, then move through model training and then fine tuning of the pre-trained model, then finally deployed the system with an interactive gradio interface. Then like yeah, by leveraging basically pre-trained models we like overcame the enormous computational costs and complexities associated with training from scratch, and allowing us to like focus and like which allowed us to focus on basically understanding how the whole of the question answering project was and how we learned and how it is scalable, not scalable exactly, but yeah. So basically we learned how to do a project and we did a project and it has helped us immensely as a team. And thank you for watching, thank you for providing us this opportunity, thank you for my teammates for helping me. uh, Please check out the link in the GitHub link in the description as well, and like feel free to leave the comments or like questions below, and like I'll be happy to help. So until next time, thank you. Happy coding. It has helped us immensely as a team. And thank you for watching, thank you for providing us this opportunity, thank you for my teammates for helping me. uh, Please check out the link in the GitHub link in the description as well, and like feel free to leave the comments or like questions below, and like I'll be happy to help. So until next time, thank you. Happy coding.